know how to screenshot as we go along, just so that you don't miss anything. But let's get straight into it. Right, so where should we come? Right, we have been looking at essentially relationships. And I said in our last lesson that one of the most, or rather two of the most important ways to express or to be able to describe relationships is through equations and is through graphs. Now, tables are also very useful to us because it allows us to plot a graph, which we're eventually going to get to. But from sort of like grade 9 up, equations and being comfortable with equations is so important. So what I want to have a look at here is using either the words or the flow diagram, whatever it is that I've put here in our examples, we want to try and write down an equation for each of these relationships. So guys, remember, when I write down an equation, what I'm looking for is a situation of y equals something. Now, this y is coming from the fact that once I've performed these operations, I get an output, which is represented by y. And this is performed on x, which is our input value. So if we put a number in, remember I said it's like a little number machine. We put the x in, performs all these operations on x, and then we get y. And that's our output. So according to this rule, my input x is going to be multiplied by 10, and then I'm going to add 15, and I'm going to get my output. So I don't know if maybe someone wants to try. You can put it in the chat or you can raise your hand. What would the equation look like to describe this relationship? Oh, Palesa's on it. Palesa, tell me.
Ma'am, it'll be y equals 10 plus 15x.
Okay, so what are we timesing x by? Are we timesing x by 10 or 15?
Oh, ma'am, we're timesing by 10.
Good. So do you agree it should be 10x?
X, yes, ma'am.
Plus
50.
Excellent. Well done. Right. So guys, this is what we call an algebraic equation to describe our relationship. Now, it's perfectly fine to have x10, but convention, or like the standard way we usually write it, is to write it with the number and then the letter. The reason I'm going to point this out is because as you start to get into the specifics of graphs, we often refer to, or there's something special about the number in front of the x. So if it's in that order, it's just going to make your life easier, but it is the same thing at the end of the day. Right, so what we know we can do is we can take each of those, excuse me, each of those inputs, whatever they may be, and we can apply the rule to get an output. So if I now give you specific inputs, hopefully you can now use this rule to get the output. So what I'm going to do is I'm going to give you a couple, and then I'm going to give you a second to give it a go. What I'm going to do is I'm going to label them A, B, C. Let's do 4. We don't need to do all 7. So your input A is going to be -3, input B -1, input C 0, and input D 2. So taking each of those inputs, remember basically what we want to do is we want to take this value, which represents x, and we want to substitute it into our equation in order to get the output. So I'm going to give everyone a second to have a go and give it a try. If and when you are ready, you can either put your answers in the chat. I've given them numbers. You can list your answers A, B, C, D. That's it. Or you can raise your hand and I will get some answers from everyone in a second. Okay, we're just going to give everyone a chance to try it.
Yeah, doing great, my pebs. You're doing really well.
Okay, Linnell, do you want to give us the first one? What is the output when our input's -3?
Oh, ma'am, the answer will be -15.
Okay, can you explain how you did it for us?
Ma'am, because I said -3 times 10 plus 15.
Good, and what's -3 times 10?
Ma'am, it's -30.
Good. So guys, negative 30 plus 15, exactly as Lionel said, is negative 15. Excellent, well done. Amiki, do you want to give us the output when the input is negative 1?
Ma'am, the answer is 5.
Good, and how did you get it?
I said 10x, which is negative 1 plus 15.
Excellent. So 10 times negative 1 is negative 10 plus 15 gives me 5.
5.
Well done.
Thank you.
Alrighty. Oh, so many hands, guys. Well done. Tato, do you want to give me the output when my input's 0?
Yes, ma'am, it's 15.
Excellent. Now, what is, where's my question in my head? What is 10 times 0?
10 times 0. It is 0.
Excellent. So guys, what you need to remember is that whenever you're timesing something by 0, you actually just have 0. And so that's why Title said it's essentially 15, because 10 times 0 is 0 plus 15 just gives me 15. Well done. Okay. Oh, so many hands. Theo, what is the last one? What is our output when our input's 2?
35, ma'am.
How did you get that?
I said 10 times 2 and it's 20, and I plus it by 15 and I got 35.
Excellent. 10 times 2 is 20 plus 15 is 35. Right, guys, very nicely done. We're going to do lots more. So those of you with hands up, there will definitely be chances for you to give me more answers. Tabang, Tato, and Onati, I still see hands, so you can leave your hand up if you've got a question. If you don't, please lower it, and then we can have a look at the next one. Awesome, guys. Well done. Right, take your screenshot if you need. And let's have a look at our second relationship, which is describing an output number. And remember, this is y, is equal to an input number times 7 plus 10. So how can I write that as a neat equation? What would the equation look like for this relationship? Claire, what do you think?
I think it will be 7x plus 10.
Excellent. So y is equal to 7x plus 10. Fantastic. Well done.
Thank you.
Right, again, guys, I'm going to give you some inputs that I want you to go and find outputs for. I'm also not going to do all of these. So let's do a -5, a 3, and a 9. I'm going to give you those 3. So here's A, here's B, and here's C. I want outputs if those are your inputs. I'm going to give everyone a chance to give it a go, and then I'll take some of the hands that are up. Nice. Okay. Tabang, what about your English? What is your output for the first one?
Ma'am, I said -5 times 7, ma'am, which is -35. Then I said plus
Good.
10, which is 25, ma'am. -25.
Good. Well done. So guys, our output, -25. Tabang explained how we get there. Well done. Papedi, tell me the output when my input is 3.
Ma'am, I said 3 times 7 equals to 21 plus
Good.
10 equals to 31.
Excellent. Well done. 31. And again, has been explained. Hopefully we all understand how we get there. Well done. Unati, what is the output for the input of 9?
Okay, so I did 7 times 9 equals 63 plus 10 equals 73.
Excellent. Well done. Nice. Okay, guys, so this is sort of where we're going. If we can do this, we're capable of really finding any graph that we want. I'm actually gonna let's give this one a go. Actually, no, you guys are on this. Let's skip to this last one. It's a little bit harder. The input number is multiplied by 3, divided by 2, and then 7 is subtracted from that quotient. Now, just so that we're all understanding, I think the only thing that might be a bit confusing is this idea of a quotient. Sorry, I'll go back for you to screenshot now. Let's do that. I get so excited and then I just rush. If you need to take a screenshot, please do, and then I'll go back down to that question. Okay. So I'm going to read it again. The input number is multiplied by 3, divided by 2, and then 7 is subtracted from that quotient. Now, guys, remember, quotient refers to the operation of division. So once you have divided what you need to divide, we then subtract 7 as a last step. So I'm going to give you guys a second to think about it. If you want to have a go, you're welcome to raise your hand. It is a slightly trickier one, but I do have faith that you guys can do it. But I'm going to give everyone a chance to just think about it. Scarlett, would you like to have a try? Scarlett, you there? Okay, I'm going to give someone else a chance. Conce, would you like to give a go? Have a go. Your English.
Ma'am, it's going to be x multiplied by 3 divided by 2 and then minus 7.
So like that?
Yes, ma'am.
Excellent. Well done. So guys, remember 3 or x times 3, we can write as 3x. I'm then taking that and dividing it by 2. And then I'm taking that whole fraction, or the value of that whole fraction, and I'm subtracting 7. So this was a slightly trickier one, but you guys are on it tonight, so I don't really feel too bad. And so if you didn't get it, don't stress. I do like what I'm seeing in the chat of sort of what Theo's got there, of a bracket of the fact that it's the 3x divided by 2, that it's then got 7 subtracted from it. And this this idea of the fact that it is the 3x that we divide by 2, as Palesa put on the chat as well. So very nicely done. If you didn't get it, don't stress. It was a little bit trickier, but that is essentially our formula. So again, I'm going to give you some inputs. I'm going to be a little bit mean, but it's all right. X and Y. So let's do inputs of -4, 0, 3, and then I'm going to put a little star here to give you a bit of a challenge. What if I gave you an output rather than an input? So I'm going to tell you that your output is -4. I'm asking, what is your input? Right, so I've got 4 questions that I'm essentially asking you here. I'm going to number them. So nice, easy ones for A, B, and C. I just want the outputs. Question D, I've been a little bit mean. I've given you the output. I want to know what the input was. So what was X that I put into this equation in order to get that Y value of -4? Right, we're going to give everyone a chance to give an answer. You can put it on the chat. I can already see some hands, which is awesome. I'm just going to give everyone a chance and then we'll go through it. I'm hoping that A, B, and C won't be too bad. D, like I said, a little bit trickier. If you're struggling, I'll give you a hint that if you substitute -4 in place of y, you still have an equation and you can go and solve. That's my hint.
We can do this, my babes. We can do it.
Seeing some good answers so far. I'll give everyone another minute or so. Okay, Becky, do you want to tell us what the output is when our input is -4?
The output is -13.
Good, well done. So our output here is -13. Reason being, when I substitute in, when I substitute in my -4, I've got 3 times -4 in my numerator, divided by 2, and then -7. 3 times -4 we know gives us -12, divided by 2 minus 7. -12, oh gosh, divided by +2 is a -6. And -6 minus 7 gives us exactly -13. Well done. Okay. Who else do we have here? Ntaba saying, give me the output for an input of 0.
Hello, ma'am.
Hi.
So the output of 0 is -7.
Good, well done. So do you agree that the whole fraction, I want to say, falls away because of the 0?
Yes, ma'am.
Good, well done. So guys, because it's a 0, 3 times 0, we've just said is 0. 0 divided by 2 or 0 divided by anything is 0. And so whenever you've got something with a division or a multiplication, I'm actually going to restart that sentence. Whenever you've got a multiplication of 0 or 0 divided by something, it's 0.
Yes.
Good, well done. Alrighty, so we've got one more before we get to that tricky one. So let's see who is going to be our lucky winner. Theo, tell me the output for C.
Ma'am, it is -2,5.
Okay, good. Now, how did you get that? Can you walk us through it?
Yes, ma'am. I said 3 times 3, ma'am, and I got 9 and divided it by 2, and I got let's think, 4,5, and I
Good.
minus it by 7, then I got 2,5 minus
Excellent.
2,5.
Excellent. Well done. Okay, so guys, sometimes we get decimals or fractions. It really doesn't matter as long as you're doing your substitution correctly. Just so that we're all on the same page, -2.5, you can write as -2.5, so as a mixed number, or you can write it as -5/2. I usually write it as an improper fraction, but really all of them are the same, so it doesn't really matter. Okay, so let's have a look at this last one. So I still see some hands, which I'm assuming this means that we are feeling comfortable and confident to try the last one. If you're not raised, if you're not, lower your hand and we can then not pick on you. Kwakukle, do you want to have a try?
Okay. Ma'am, I said -4 plus 7. Then I got 3.
Mhm.
No, sorry. Oh yes, I did get 3. Yes. Then I said 3 times by 2, which I got 6, and 3. Oh, I'm sorry. 6 divided by 3, and I got 2.
Excellent. Well done. Nice, guys. So D in this case is 2. Now, Kokukle's walked us through this. I'm going to write it all out so that we know what's going on. But if you did it, your answer there for D should be 2. Okay, so the question is how? Well, let's have a look. We know that what I've given you here is the Y value. So if we substitute in place of Y, we would have -4 is equal to 3x over 2 minus 7. And so what we have here is an equation. And this is what I love about maths. The fact that so many sections overlap. Technically, I'm asking you to solve an equation here. We're talking about graphs, but I'm asking you to solve an equation, and we know how to do that. So when we solve this equation, what we need to do is we first need to add 7. Remember, we use those inverse operations on both sides. And so what I now have is a -4 plus 7 is equal to 3x over 2. -4 plus 7 is 3, is equal to 3x over 2. Now I've got that fraction that I need to deal with. Not a huge fan of fractions, but that's fine. We can deal with it. We will times both sides by 2, because what that does is it cancels out the denominator. Oopsie daisies, sorry. And so now what I have is 6, because 2 times 3 is 6, is equal to 3x. And then we know that if we want to get that x alone, I need to divide the coefficient away. So I'm going to divide both sides by 3. And so what I actually end up with, I'm going to go here, sorry, is 6 divided by 3, which is equal to 3x divided by 3. Now we know that those 3's will go away, leaving me with just an x. And 6 divided by 3 is 2. And so what we've solved for is that input value that I was looking for, the fact that x is equal to 2. And now, guys, you can go and check that. If you want to double check that you've done that correctly, what we'll do is we'll take this input value that we've just found, we can substitute it in place of x in my original equation and check that I get -4. So if we quickly do that verbally, substituting the x in here, I get 3 times 2, which is 6. 6 divided by 2, which is 3, and 3 minus 7, which does in fact give me -4. And so I've solved correctly for my input value. Very well done, grade 8s. That's awesome, awesome work. I threw a span in the works there and you just took it. Well done. Right, so what I will do is just make this a touch smaller in case you want to screenshot everything. We do have a brain break here, and that we will put up now. I'm just going to let everyone screenshot. We're going to do the brain break same as last time, where we're not going to say anything. We're going to give you some time to go and try it. First person who gets the answer on the chat, so please make sure you're putting your answers on the chat. We will get to raise their hand and explain it to us. Righto. So here is, oopsie, our brain break. We've got, I was corrected in the last class, now I can't forget. It's a mummy, not a zombie. I thought it was a zombie. So this is the mummy. We've got some, I don't know, ghost balloons and a lollipop. So I need you guys to work through these steps. Okay, it'll go away eventually. Work through each of these equations in order to tell me the value of this last one over here. Right, so we're not going to say anything. The second you have an answer, please put it in the chat, and Yolanda and I are going to keep an eye out for the correct answer so that we can pick that person.
Let's go, my pebs. Let's see who's the winner of the brain break. Let's see who's taking this one home. I was about to say the name of the student, and I'm like, oh, this is this is just them giving me a hint of the answer, guys. Let's go, my babes. Let's go. Let's go. We haven't seen the right answer, so keep trying. Remember, don't give us like, step by step. At this moment, we're only looking for the final answer. So do your calculation on your book, and then you give us your final answer, and the first person to put it on the chat is the winner. So far, no right answers. Keep trying, my pips. Remember that there's some trick over there. Don't fall for it. There's a trap on the final answer that you need to give. Look at every single picture nicely and carefully.
So far, looks like we're on the right track.
Yeah. Let's go, my babes.
Sure.
Now,
The
let
lady,
you know.
a little too high.
Definitely not. But no. Let's go, my babes. This is fun. We're doing it in a fun way. Let's go.
I like doing it like this.
Keep
And I
it
like that we're
coming.
putting it on the chat. We're helping each other by putting stuff on the chat there.
Oh, they got it, guys. Well done. That was fast. Kwakuhle. Well done. So, Kwakuhle, if you're not shy, you're allowed to raise your hand so you can explain to the whole class how did you get that answer, okay?
There we go.
And Khonse also got it right. So everyone who got it right, you're allowed to raise your hand so you can give a step by step, okay?
Okay, I see Kwakuhle here.
There we go. Kwakuhle, explain it to us. Teach us.
Okay, first of all, I said 60 divided by 3, and I got 20 for the first month. And for the lollipops, I got I did it weird. I didn't do like the mathematical way or something like that. I did it the long way. And
so what is the long way?
So I
guessing.
No, I didn't guess. I just nerves are getting on me. Sorry.
Okay, can I ask a question while you gather your thoughts? What is one mummy worth?
10.
Okay, cool. Oops.
Yes. So I so I didn't guess. I just substituted it.
Okay.
Like
good.
Yes. So I said 10 times 7.
Good.
Which I got 70 plus 10, which I got 80.
Excellent. So now we know these weird balloon things are 7.
7, yes. And for the third row, I knew the balloons were 7, so I said that the lollipops will be 9 times 9, which will give me 81.
Good. Now, in this last step, Kwakuhle, what is the value of this first thing over here?
14.
Excellent, because we've got double. Now, which operation do we do first? The plus or the times?
Multiplication, which is 9 times 10.
Which is?
9 times 10 now.
Sorry, yeah. What is 9 times 10?
90.
Good. And then 90 plus 14?
104.
Excellent. Well done. Nice, guys. So that was our brain break. I just am going to prepare you now. I want to say the next lesson, I've definitely upped the difficulty level of our brain break. So get excited. Nice, guys. Okay, so there it is. 104 was your answer. Double check your operations as you go along. any mistakes is probably just a silly mistake. So don't stress about it. And I know there were a couple other people who got the right answer. So well done to everyone who got that. All righty. So let us get into the fun stuff. Now, I know this is already filled in, but this is already filled in because if you remember, this is what we actually spoke about in our last lesson. So we did these equations together in our last lesson, and we sort of ended off by drawing one of the graphs. So I'm actually just going to quickly pull up what we did in the last lesson so we can all see. And hopefully this is going to refresh some memories. What we did was we drew the first graph of the equation y equals x plus 4. And so we didn't do the rest, but that's what we're going to have a look at now because there's some cool graphs that we're eventually going to start drawing. So let's have a look at the other relationships that we had and let's see how these would translate into graphs. So if we have a look at our second equation that we had dealt with. So again, guys, we came up with these equations together. We just now want to actually draw the graphs. If we look at the second one, our second one is 3 times x plus 5. So we're gonna go up and down, but it's all right. If we put that with our table and we say y is equal to 3 times x plus 5, we know that because we have an equation, we can get inputs and outputs, right? So here's our input, here's our outputs. We really don't need so many, so I'm just going to pick a couple. Let's do -2, 0, 1, and 3. So we can ignore these blocks at the end. So I'm going to give you like 2 minutes. I want the outputs for those 4 inputs over there. When you're ready, you're welcome to pop it in on the chat, or you're welcome to raise your hand and I'll get some answers.
We can do this, my babes. Let's go.
Okay, Palesa Mudipa, do you want to give us the first one?
Hi, ma'am. So
Hi.
A would be 9.
Yes, quick math in my head. Right, just so that we're all clear on what we're doing, y is equal to 3 times, now I substitute in -2, so -2 plus 5. Now we know -2 plus 5 is then a +3, and then exactly as Palesa said, 3 times 3 is 9. So my output there is 9. Excellent. Becky, do you want to give, oh, where did you go? Am I losing my mind? Do you want to give us the output for B?
Ma'am, the output is 15.
Excellent, 15. 0 plus 5 is 5, and then 5 times 3 is 15. Well done. Lilita, do you want to give us the output for 1?
Ma'am, for 1, I got 18.
Excellent. 1 plus 5 is 6. 6 times 3, 18. Very nice. Sipiwe, do you want to give us the output for 3?
Yes, ma'am. And good evening.
Hello.
I think D is 40.
Okay, let's do it together. What's 3 plus 5?
8, ma'am.
8. And what's 8 times 3?
24.
Good, well done. 24. Very nice. Well done, Spiwe. Okay, guys, so those are our input and output pairs. I really chose some gross values here, but it's fine. We soldier on. Right, so remember we spoke about the fact, and if we don't remember, that's cool. I'm going to rehash it now. We spoke about the fact that what these pairs do for us is they give us coordinates. So we've got a coordinate of -2, 9, 0, 15, 1, 18, and 3, 24. And because these are all coordinates, they follow an XY setup. And so what that means, I'll come back if we want to screenshot in a second, is that we can put these onto a Cartesian plane. Okay, so now I have not done this very nicely, but it's fine. 5, 10. Now remember, our set of axes needs to have the numbers on it. You can see that my scale is going up in 5s. And as long as I keep that consistent on the x-axis, that's okay. I can do a different scale on my y-axis. That is also fine. But I am going to keep it the same just because I obviously need to go up to quite a high number on my y-axis. And so what we can now do is hopefully plot our points on our set of axes and get a graph that represents this relationship. So let's go and plot these points. Our first point was -2, 9. So what I want to do is I want to just do this. Actually, let's pick a better color. -2, 9 will be around there where I put that red dot. Obviously, guys, my axes, because I'm going up in 5s, I'm getting it as accurately as I can. 0, 15 is now on the y-axis. And if you think back to our transformation geometry conversation, we always saw that whenever we're sitting on the y-axis, the x is 0. We've then got 118, which would be about there. It's not a great point, about there. And then 3, and it would be very helpful if I wrote the right thing down, 324, which takes us to about there. Now, just because I've got a hands here, Amiki, what sort of shape am I getting if I join these dots?
Ma'am, you're getting like a linear, if that's what you call it.
Excellent, well done. So guys, if I now join these dots, and I'm going to do my absolute best to join them as well as I can, but I can already see this is going pear-shaped. If I now join these dots with a ruler, obviously, I'm getting a straight line. Now, obviously, my dots are a bit off because my straight line, actually, I don't like that at all. I'm going to try again. Right, if I draw my straight line with a ruler, obviously you will do it with a ruler, I'm not. We get exactly, as Amiki said, a straight line. And so this is one of the types of graphs that we are going to take all the way up with us until matric, is these straight line graphs. Now, we're going to hopefully start to see some patterns in how we get straight line graphs. But for now, it's more just important that we can draw the graph. Right, so if you want to take a screenshot, what I'm going to do is I make this tad smaller so you can get everything all in one go. I see some hands. So Tato, Unati, and Linnell, if you have a question, you can obviously leave your hand up. But if you don't, please do lower it just so that I'm not missing anyone. Unati, do you have a question?
Evening, ma'am.
Hi.
I was wondering, can you still use distribution to calculate the x, y?
Yes, absolutely. So, I mean, it's really up to you how you choose to do it. We probably wouldn't actually give it to you like that. We'd probably give it to you distributed already, but you definitely can, yes.
Thank you, ma'am.
Cool. Okay, guys. So let's have a look at the next sort of graph that we had a look at together. So the third equation that we spoke about, if we just scroll up again, was this equation of y is equal to 3x minus 2. So there we are. Y is equal to 3x minus 2. I'm going to give you some inputs and some outputs. So let's go minus 2, 0, and 1. We're going to just ignore those. So I'm going to give everyone a second I would like you to work out your outputs when your input is -2, 0, and 1. Can I just remind everyone to be on mute? And then if and when you're ready, you're welcome to raise your hand and I'll take some answers. I already see some hands going up, which is awesome. Nice, guys. I feel like we're already there. Sammy, do you want to tell us the first one?
Evening, ma'am.
Hi.
So for the first one, it's -2 multiplied by 3, which is -6.
Good.
-6 minus 2 is 8.
Good. Well,
-8.
good. -8. So our first output is -8. Excellent. Well done. Thank you. Right. Tankosi, do you want to give us the second output?
Hello, ma'am.
Hi.
For number 2, it's -2.
Excellent. Well done. -2. Remember, guys, anything times 0 is 0. Thank you, Tankosi. Let's see who we have here. Oh, nice. Okay, I hope I say your name right. Sena, the third one. You can correct me as well.
My answer for the last one was 1.
Excellent. Well done. 1. 3 times 1 is 3. -2 just gives me 1. Fantastic, guys. Well done. So now we know that we can take these beautiful coordinate pairs and we can plot a graph. So our coordinate pairs are -2, -8, 0, -2, and 1, 1. Right, I will come back so you can screenshot this. I just want to make this graph a bit bigger so we know what we're dealing with. So 2, 4, 6, 8, 10. I really should put numbers on these beforehand. I clearly don't think all the way through sometimes. Oh, yeah.
Our last stretch, my babes. We're getting there. We're getting there, my people.
I've also learned my lesson. I'm going to put numbers on in future because, geez, that's tedious to have to sit and watch. Okay, guys, let's plot these beautiful points. -2, -8 is then somewhere down there. 0, -2 over here, and then 1, 1 is sitting directly there. Now, again, we're seeing we're getting this straight line vibe. Obviously, you will use a ruler, but we've got a straight line. Now, that sort of makes sense. If I just sort of go like this, these equations look quite similar. If we go back and we distribute this as was said to us, this is 3x plus 15. The equations look similar, not only because they both have coefficients of 3, but because it's an x term and a constant term. Now, what happens when that is not the case? And we've got 10 minutes and I really want to show you this graph because it's a really cool graph. Our last equation that we had, and I would take a screenshot in the meantime, if you need to, so that I can then zoom up. Right, the last equation that we had was the equation y equals x squared. Okay, so this was a bit different. Hopefully we all agree because now there's an exponent to x. So let's see what happens. Again, input outputs. I'm going to give you a few outputs here. So let's go -2, -1, 0, 1, and 2. Just to save some time, even though I know you can all do it, I'm going to just give the answers for this because I don't want to run out of time because I think this is very cool for you to see. -2 squared, and I just want to make a point here. We are taking -2 and squaring it, which means that we are taking -2 times -2. I know that when I multiply two negatives together, I get a positive. So this is +4. Same thing's going to happen with a -1. -1 times -1 is +1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So now I've got my coordinate pairs. Now, people with hands up, I'm about to pick on you. So if you don't want to be picked on, lower your hand. Okay. My question is, what do you notice about your... That is fair though. It's fair. My question to you guys is, what are you noticing about the outputs? Because as we saw in this table here and in the last one, all of my outputs are different. So Palesa, tell me, what are you noticing about the outputs here?
Ma'am, the outputs will remain the way they are in the table.
Okay, what do you mean by that? Expand on that a bit.
Ma'am, right? You said y equals -2 squared. So ma'am, the y will be...
The y, say again?
The first y will be -2.
Yeah.
And ma'am, we are keeping the same x coordinates we got from the table.
Okay, so all of my x coordinates are different, but it's my y coordinates. Some of them are the same. Do you agree?
Yes, ma'am.
Okay, so guys, what you need to notice is that there's almost like a pair, and this sort of makes sense. -1 and 1 give me the same answer, but that makes sense because -1 squared and +1 squared give me the same answer. -2 and 2 give me the same answer. Again, this makes sense. So hopefully what we're seeing is that on the negative x-axis and on the positive x-axis, I'm getting the same outputs. So let's go and plot these points, and I've written them down here in a list just so that we've got it. And again, I'll come back so that you can screenshot. Let's go plot these points for ourselves and see what we get. Again, like made choices here. 2, 4, 3, 4, 1, 2, 3, 4. Okay, I'm not writing in the numbers, it goes up in ones, because really. Right, if we go and plot these points, our first point that we had is -2, 4. So here's -2, I'm going up to 4, so there's my point. I've then got -1, 1, there's -1, there's 1, there's my point. I've got 0, 0. That's all fine and well, but now look what happens. I go to 1, 1. I go to 2, 4. What we kind of have here is no longer a straight line. It almost starts to look like a U shape. And that is exactly what we get. When we plot this graph, we get this U shape. And you can almost see, and this goes back to our transformation geometry, there's a bit of symmetry going on here. If I take this y-axis, I've got a mirror image on either side. It's like the arms are folded. And so what I've got here is a completely new type of graph, but it still represents a relationship between my x and y. And Tandem Corsi has very much put it on the group as a star. This is what we call a parabola. Now, this is not something you need to know the specifics of. Just it is important for you to see that sometimes graphs aren't just straight lines. They can be curves. And this is an example of one. Okay, I see a hand. Tiamo, do you have a question? No? Alrighty, guys. So I hope that this makes sense. We are going to do a few more of these on Monday's lesson, so don't stress too much. But it is important to know that graphs don't always have to be, or aren't only straight lines. Graphs can be curves. And this is what's really cool. And we're going to start to investigate this more